Hi everyone, welcome to Ladboy Coding. Today, we're going to solve problem 621, Task Scheduler. And we can see that lots of companies like it. So let's first go over the problem and the thought process. Given a char array representing the tasks CPU needs to do, and also given an idle period, this means that after this idle period, the CPU has to go idle to take a rest and then continue to process the task. We need to return the least number of intervals the CPU will take to finish all the given tasks. So what does this mean? The least number of intervals. We need to minimize the idle period. So this problem will be a greedy problem. How do we minimize the idle period? We need to process the task that has the most frequency first. For example, the task A appears 3 times and task B also appears 3 times. The max frequency is 3. So we need to process A first. So let's first go over the algorithm here. We need to use a heap, a max heap, a priority queue to extract the task that have the most frequency. So first, indeed, we need to count the number of frequency for each task. So in this case, task A appears 3 times and task B appears 3 times. So now we can put the number of tasks and the task name into the max heap. So now the heap becomes 3A and 3B. And we will also track the time period. And we know the idle period is 2. So let's get started. First, we need to get a task from the heap and then increment the time slot. We will subtract 1 from the task because the CPU has already processed the task. And then we get another task from the max heap. Subtract 2, increment the time period. And now notice that the time is not larger than the idle period. And it is equal to the idle period. So that means the CPU needs to go idle. And we have nothing on the max heap. So we simply increment the time period. Then this is the 4th cycle of doing the task. And we know that we still have some pending tasks to do. So we put each task in the pending task back to the max heap. And then we acquire a task from the heap again. Subtract 1, increment time. Get a task. Subtract 1, increment time. And then CPU goes idle. We put the task back to the heap. And let's get a task from the heap. Subtract 1. and increment. Subtract 1, increment. So now notice that we have nothing on the heap, and all the pending task is done because the frequency is a 0. So we can break the loop and return the time period. So this is the algorithm, and let's see the implementation. So there are still a few implementation detail to take care of. First, we need to get the frequency of each task. And let's use a dictionary for task in tasks. If we see the task in the dictionary, we just add 1. Otherwise, we put it in the dictionary. Let's print our task dict. So yes, task A appears 3 times, task B appears 3 times, and then so in this process, let's first go over how to use heap in Python. We will use a module called heap_queue. By default, the heap in Python is a min heap. Let's see an example. We use heap push to put an element in the heap. Let's print the heap. One, two, three. And then let's use the function heap pop to get the smallest element from the heap. So this should give us 1. And to demonstrate that the heap push will create a heap, let's reorder the task. And now the heap pop will still give us 1 because it is a min heap. And then the heap will give us 2. And then the heap will give us 3. 1, 2, 3. So, but this is a min heap. How can we use it as a max heap? We want to extract 3, then 2, then 1. Let's add a minus sign. So now, if we print the heap, it will yeah, let's save it. Oops, never mind. Heap. Yeah. And then if we use a heap pop, it gives us 3. But the original number is 3, not -3. We can add a minus sign. So yeah. And then it will give us 2 and 1. So this is how we use max heap in Python. So now let's code the rest of the algorithm. We need to have a pending task array here to keep track of all the pending tasks. And we need to also initialize a variable I to make sure the CPU is within the idle period. So this is the setting. And let's first put our task into the max heap. Notice that what we don't care about the name of the task. We care about the frequency of the task. So we only need to append the frequency into the heap. If the frequency is larger than a 0, then we should put it into the heap. Yes. So let's see our heap. Yes, -3, -3. So now we can do the rest. Use max heap and a pending task array to model the CPU execution. When heap is not empty, we need to have a pending task, and we need to make sure it is within the idle period. So what do? We will, so if the heap is not empty, we will get a task. Notice we add the minus sign here, so we need to add the minus sign here to convert a task from a negative integer to a positive integer. So if the task is larger than 1, what do? We put it into the pending task. And we increment our time slot. So if there's no heap. And there's no pending task. We just a break. Otherwise, we need to increment the I. And then after this cycle is done, we need to put the task in pending task back to the heap. So after we are done, we just need to return the time period. Let's run our algorithm. So yes, we need to subtract 1 each time to model that CPU complete the task. So to visualize this process, let's print our heap. See, in the first step, it's 3 and 3, and then becomes 2 and 2 and 1 and 1. So now let's submit our algorithm. We are done. Okay, so let's analyze our time complexity. The time complexity would be O of n. We need to process the number of tasks, and there are n tasks. So the time complexity is n.
Okay, thank you very much for watching. If my solution helped you, please feel free to leave a comment and subscribe to my YouTube channel. Thank you very much and have a good day.